Hello YouTube. Today we will be covering how to find the integral of sine cubed over sine cubed plus cosine cubed dx. The last time I uploaded this video, I made a really dumb algebra mistake, but I'll be correcting it this time. So we'll set this integral equal to a. Now we can create and define another integral, which is similar. This time it's cosine cubed of x plus sine cubed over cosine cubed dx. Now we're still trying to solve for a, but I just defined another integral b just for the purpose of making it easier to solve this problem. So one thing I'd like to note before we start going into this problem is that a is equal to 1/2 of a plus b plus a minus b, because the b and negative b cancels out. A plus a, 2a times 1/2, that's a. So now let's get into it. So let's start off with doing 1/2 is equal to a plus b. So that's integral of sine cubed of x plus cosine cubed over sine cubed plus cosine cubed dx plus integral of sine cubed minus cosine cubed over sine cubed plus cosine cubed dx. So we can just make this integral of 1 dx, which is just x plus c1. Now this part's a bit harder, so we already know this part. So we know a is equal to 1/2 integral of, or 1/2 times x plus c1 plus this integral here, sine cubed x minus cosine cubed over sine cubed plus cosine cubed. So now the question is, how do we evaluate this expression? Because this expression is a bit harder to do than this one, obviously. So we'll cover various techniques to figure out how to do that in this video. Not various techniques. We'll use one technique to find it. So we're trying to find 1/2 x plus c1 plus integral of sine cubed minus cosine cubed over sine cubed plus cosine cubed dx. Okay, now we have room on this board for everything else. So first of all, I'd like you to recall that there's a cubic polynomial expansion that you may have learned in Algebra 1 or 2, where if you have a cubed minus b cubed, that's equivalent of a minus b times a squared plus ab plus b squared. Similarly, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So we can set this trig in this thing. We can set a equal to sine of x, b is equal to cosine of x. So now we can equate sine cubed minus cosine of cubed to this top expression here. So that's sine x minus cosine x times sine squared x plus sine x cosine x plus cosine squared over, we can equate this bottom part to this second equation. So we have sine x plus cosine x, sine squared x minus sine x, cosine x plus cosine squared x dx. This doesn't look like an x. Okay, so now this is equal to sine x minus cosine x. And then if you remember your Pythagorean identity, sine squared plus cosine squared equals 1. So 1 plus sine x cosine x over sine x plus cosine x times 1 minus sine x cosine x dx. Okay, so now where do we go from here? Well, let me just erase this. So now we kind of know where we are at right now. So we're trying to find the integral of sine x minus cosine x 1 plus sine x cosine x dx over sine x plus cosine x times 1 minus sine x cosine x. And for now, we're just going to ignore these terms because our focus is evaluating this integral. So we can use an interesting U-sub to proceed in this evaluation. So here we're going to do U equals sine x plus cosine x, which would mean that du is equal to cosine x minus sine x, all that times dx. And you may ask how we got this U substitution. This is kind of just a technique, a special technique used for this integral. There isn't really any way to just look at it and know how to do this immediately. I mean, I guess a telltale sign is the sine x minus cosine x, sine x plus cosine x, and this pattern cosine x minus sine x, where negative du is equal to sine x minus cosine x dx. I guess that could be a telltale sign that there may be U substitution involved, but it's not exactly clear. This is just an interesting technique that was used specifically for this integral. So we can set sine x minus cosine x to negative du. Sine x plus cosine x is u. But what do we do with this 1 plus sine x cosine x and this 1 minus sine x cosine x? Well, we can use a bit of algebra to find sine x cosine x in terms of u. So we know that u is equal to sine x plus cosine x. So now we could square both sides. So we now have sine squared x plus 2 sine x cosine x plus cosine squared. But sine squared plus cosine squared is just 1 plus, it's just 1, and then we still have 2 sine x cosine of x. So that would make 2 sine x cosine x equal to u squared minus 1, because you subtract both sides by 1, and then divide both sides by 2. So now we can make this substitution. So this is equal to the integral of negative du times 1 plus sine x cosine x, so that's 1 plus u squared minus 1 over 2 du over u, because that's sine x plus cosine x, times 1 minus u squared minus 1 over 2. Okay, so now if we simplify this out, we get negative 1 plus 1/2 u squared minus 1/2. So that would be 1/2 plus 1/2 u squared over u times 1, or now it's 3/2 minus 1/2 u squared. So this is equal to, if you just, du, let me just get rid of this now. Okay, so now you can multiply the numerator and the denominator by 2u, or sorry, negative 2. So now we have 1 plus u squared du over, multiply both the numerator and denominator by negative 2. So now we have u times u squared minus 3. So now we have a system of equations to solve. So let me just get rid of all of this stuff. So we could just say that this is 1 plus u squared du over u times u squared minus 3. Okay, so first of all, to get to the system of equations, we have to do partial fraction decomposition. So let's quickly do that. So we know that 1 plus u squared over u times u squared minus 3 is equal to a over u plus b over u plus 3, u plus square root of 3 plus c over u minus root 3, because that's the factorization of this. This is equal to u plus root 3, u minus root 3, difference of squares. So now we can just do the algebra. So this is equal to a u plus root 3, u minus root 3 over u squared minus 3 plus b u minus root 3 u squared minus 3. Okay, and then we all have plus c u plus root 3 u squared minus 3. Okay, so this is the part I made a mistake in my last upload of this same integral, but this time I'll be more cautious and I'll try to avoid that mistake. Okay, so let me just get rid of this quickly. You guys know what all this is. So this is a squared, or rather a times u squared minus 3 plus b times u squared minus root 3u plus c times u squared plus root 3u. That's equal to the top 1 plus u squared. Okay, now let me get rid of this. So now we know that, or we could pretend that there's an imaginary coefficient 1 next to the u squared. So we know that the u squared terms group together. So this is a u squared plus b u squared plus c u squared. So a plus b plus c u squared equals 1 times u squared. So that's the same thing as saying a plus b plus c equals 1. And then there's going to be an imaginary plus 0u, since that term doesn't exist. So we have a negative root 3 bu, so negative root 3 b. We have a plus root 3 c equals 0u. So negative root 3 b plus root 3 c equals 0. Then we can just group the constant terms. There's just one constant, that is going to be 1. So we already know that a is equal to negative 1/3 right off the bat. Now, okay, how do we progress from here? Okay, well, we can first of all plug negative 1/3 into the equation now. So we have negative 1/3 plus b plus c equals 1. So b plus c equals 4/3. So now we have, and then we can just simplify this out quickly. So we have square root 3 b over square root 3 over c. You could cancel out the square roots. So this b is equal to c. So if b equals c, then we have to know that b equals 2/3 c also equals 2/3. A, we already determined, is equal to negative 1/3. This time I didn't make any mistakes in the algebra. Be proud of me. So now let me erase all this. Keep everything but our solutions. Okay, so as you remember, this is equal to expansion a over u plus b, u plus root 3 plus c, u minus root 3. So just substitute the a, b, and c. So negative 1/3, 2/3, 2/3. Okay, now we can integrate all of this. Now we have negative 1/3 ln of u plus 2/3 ln u plus root 3 plus 2/3 ln u minus root 3 plus c2. Then we can plug this in here. So we have 1/2 x plus c1 plus all of this. So start off negative 1/3 ln u plus 2/3 ln u plus root 3 plus 2/3 ln u minus root 3 plus c2. But as you remember, our u substitution is u equals sine x plus cosine x. So, okay, so now I can get rid of this now. So we can plug everything in, but before we do that, we can just make a few simplifications here. So as you may remember from your log rules, that if you have something on the outside, ln a to the ln b times a on the outside, then you can raise b to the a power, and they would be equivalent in your log rules. And ln of a plus ln of b is equal to ln of ab. So using these rules, we can simplify this out a little. So we have ln of u to the negative 1/3 power plus ln of u plus root 3 to the 2/3 power plus ln u minus root 3 to the 2/3 power. Now we can multiply all of it, so we have ln of u to the negative 1/3 and then times u squared minus 3 to the 2/3 power. Okay, so now we can plug in our u back into this expression. So this is ln of sine of x plus cosine x to the negative 1/3 power times, do you remember u squared is equal to 1 plus 2 sine x cosine x? So u squared minus 3 is negative 2 plus 2 sine x cosine x. So negative 2 plus 2 sine x cosine x to the 2/3 power. So now we can plug this back in. And remember, C1, C2, they're arbitrary constants, so they could just add up into a C3. So, okay, so this goes here. This is just an intermediate step. This is equal to 1/2 times x plus ln of sine x plus cosine x to the negative 1/3 power times negative 2 plus 2 sine x cosine x to the 2/3 power with the absolute value sign plus C3. And this is our final answer. Last time I made an error, but this time I didn't. Thank you for watching. This was a long video, and I'll see you in my next video.